Section 4.5 has to do with congruence in right triangles, and I'm calling this section Hypotenuse Leg. So to begin, I'm asking you to just go back for 1 minute and tell whether the abbreviation identifies a congruence statement, a way to prove two triangles are congruent. And we do know that side, side, side works. Side, angle works. Angle, side, angle. Angle, angle, side. But there is no such thing as SSA. And we also said that angle, angle, angle does not work. So far, we've worked with 4. So now we're going to go to right triangles specifically. And just to begin, I want to go back and review with you what a hypotenuse is and what a leg is. A hypotenuse is the side opposite the right angle in a right triangle. And you might also want to add the fact that the hypotenuse is always the longest side. Okay, we don't call it a leg, it's the longest side, and it's always opposite the 90 degrees. And then every right triangle has 2 legs, and they are the sides that form the right angle. So our hypotenuse leg theorem that we're going to abbreviate with HL says if the hypotenuse and the leg of one triangle are congruent to the hypotenuse, and it should say corresponding leg of another right triangle, then the triangles are congruent. So if we had our first triangle ABC, and our other triangle is DEF. If the hypotenuses are congruent and one pair of corresponding legs are congruent, then that's enough to say the two triangles are congruent using HL. So I would say triangle ABC is congruent to triangle DEF by HL. Now if you look very closely at how these triangles were marked, it looks like angle, side, side, congruent to angle, side, side. But remember that we said this does not work, and it will only work if it's a right angle making a right triangle. So HL. Determine whether the following triangles are congruent due to hypotenuse leg, and if so, write a congruent statement. So on our first diagram, it looks like we have a hypotenuse congruent to a hypotenuse and a corresponding leg congruent to a corresponding leg. And so by HL I would say yes. Therefore I can say that triangle JLK is congruent to triangle MON. Now on part B, we have 2 right triangles and we have a hypotenuse congruent to a hypotenuse. But we also know that they share a leg. So by the way that was drawn, I would say, yes, I have hypotenuse leg. Now be careful when you write your statement. If I called the first one triangle ABC, triangle ABC is going to be congruent to triangle DCB. Remember on that quiz where some of you fell down a little bit on naming the appropriate corresponding vertices, that's important. So ABC congruent to triangle DCB. And then let's put it to a proof. So here we go. I am told that the side WJ is congruent to the side KZ. That was given to me. And it's already been marked. I am also told that my angles W and K are right angles. So angle W and angle K are right angles. That was given, and that was also marked for us. Step 3 would be that two triangles share that side. So I would say the side JZ is congruent to the side ZJ, and that is by the reflexive property. Anything is congruent to itself. And therefore, what am I trying to prove? That the two triangles are congruent. Triangle JWZ is congruent to triangle ZKJ, and I know that by HL. And that's pretty much all there is to it. So now we know 5 ways to prove triangles congruent.